So, hello everyone, it's me Khushi Arora, the student of Netra Institute. Today I am going to perform the Normalized Difference Vegetation Index practical with you, which we also know called as an NDVI in the short. So, let's introduce what is NDVI. NDVI is basically widely used in the vegetation index, means measure the health and the density of the vegetation on a specific area. It is used to calculate on the remote with the help of the remote sensing data, and we have to use the satellite imagery data. We also find these data from USGS Earth Explorer. So the and is the valuable in the various fields such as agriculture, forestry, and environmental monitoring. This NDVI can be calculated and analyzed by using the raster data lake. After the introduction, I'm giving here a small quote to understand with this emotionally. So, NDVI unveils us the hidden stories of our planet's vegetation, which is reminding us the delicate balance between the mankind and the nature. So, let's come to the methodology part. It consists the step of NDVI are following. The first step of our methodology is the acquiring satellite imagery. So obtain a satellite imagery data for area of interest. We have to obtain an area which we have called area of interest. So we have to go for USGS Earth Explorer for collecting our data in the satellite imagery. So these images usually come in the form of the multispectral bands, which have we also ensure that it should be consisting the red and near infrared bands, which is essential for calculating the NDVI. And the second is the import data into the ArcGIS. After collecting the data from the USGS Earth Explorer, we have to go for our further step, which is import the data in ArcGIS. So important. We ensure red and near infrared band are correctly identified with this ArcGIS software. After that, importing the data. After that, we have to calculate the NDVI. So we have a certain formula for collecting the NDVI data, which is here. The mathematical data is NDVI is equals to NIR, which is near infrared minus red band divided by near infrared plus red band. So let's explain me. First, what we have to do is acquiring the satellite imagery data, which I already acquired from USGS. So directly I am importing my data in the ArcGIS software. So I open my ArcGIS software, and firstly uh, I'm taking my area of interest in Alver shapefile, which is here. Follow it, then okay. Then here is pants. Add these pants. It's only covered this area, so I added this. After that, it's can see it's completed all of the data, but also cover the surrounding. So in this, we have to correcting our data. So we have to do first the masking process, or we have to do the NDVI process. So I'm doing here first the NDVI, after that masking. So go to the ARC toolbox. Go to the spatial analyst tool and then map algebra. And in map algebra, you have to go raster calculator. Open it. So first, For calculating the NDVI, we have to also ensure that using the float before these bands. So at this, band 5 minus band 4 divided by again float band 5 plus band 1. Then give the output file name, then save it. Okay. It's taking few minutes. So here's our NDVI of this portion only. Let me of this portion. This is the NDVI. Then so we can also calculate our NDVI portion from here, and after it we have to do our masking process. Add here the NDVI and the shape file of the album. Then click OK. So here is the extracting file, and we can also do from here. And this is our final. We can also change its color according to us. So again, let's go. So we are completing from here now. We have to go the symbolized and the where raster, in which we have to do is to symbolize our data into the categories like visualize the vegetation density. You can also change the color gram that I show recently that I was changing my classifications color so that we can easily get to interpret our data, where greener color indicate the healthier vegetation and redder color represents sparse or no vegetation. Which just means if there is the green color, it's mean there is the greater vegetation, and if there is the red color, it shows us the lesser or no vegetation. Our next step will be the perform analysis. And UVI value can be analyzed to assess vegetation health and identify vegetation cover change over time, monitor crop health, and detect environmental change like deforestation and urbanization. We can analyze easily, like we have to compare the two data, like 2019. Further, I'm comparing my data from 2019 and 2023 data. So we have to analyze that what is the changes from 2019 and what are the changes in the 2023. So here is the classification after. The step of this methodology is, which is optional, in which we have to perform our additional processing such as image classification, time series analysis, or change detection to gain more insights from the NDVI data. And our last and seventh step will be the interpret the and present the result, which is I'm showing here. It is our final output. which is interpret the NDVI result and present your finding using the map. It should be covered in the frame, giving the relation, giving the this grids, this scale bar, this the title. These are these various tools for spatial analysis and visualization to help effectively communicate your result so that we can easily interpret or other can easily interpret your result. So here I'm sharing my area of interest. Firstly, I want to describe here. Uh, I was showing here that the Arabi region in whole of our area, like which is consist the districts of Haryana, Faridabad, Rajasthan, and Gujarat. Here, an EVI of whole map has been calculated. We have selected the area of interest, which is Alwar. It, it is the area of interest which I was collect the area of Alwar. Here, I'm giving the database means the satellites data, the data acquiring date, the sensor's name, the spatial resolution. I'm here like previously, I'm sharing that I was collecting my data of 2019 and 2023. The satellite I was used to collect my data from the Lancet 8 and 9 and also 2023 Lancet 8 and 9. The data acquired is this date and the sensor OLI and TIRS in both these data. And the spatial resolution is also 30 meter. So this is the I was found my data from the geological survey means Earth Explorer USGS government site which was taken related to the satellite. So here is the comparison between the 2019 data and the 2023 data. Here I was collecting my vegetation index means NDVI of 2019 and 2023 data. So we have to compare both these data. So go to the result part. First we have to analyze from this data. So here is the result of figure 1.2 which is showing the NDVI 2019 in Aurora, which have a category like sparse vegetation, moderate vegetation and severe vegetation which shows the different percentage. Here is the so here it shows the sparse vegetation and the moderate vegetation and the very moderate vegetation means the classification of the vegetation. So these are the categories. Sparse vegetation, which area covered is 219.28, which is in the square kilometers data. And the moderate vegetation cover 1303.24 and the very moderate consists 250.39 in the square kilometer. And the values of these data's classification is minus 0.05, the sparse vegetation to 0.11 and the moderate vegetation is 0.11 to 0.15. So according to this above written data, we can say that the sparse vegetation constitute 2191 in the square where moderate vegetation is this. And in this 2023 data, here's this, you can see the slightly difference in the 2019 and 2023 data. Here you can see the sparse vegetation is 2117.43 and the moderate vegetation is 1300 and the very moderate is 57439. So we can easily compare with the help of the chart slides and like bar graph and the pie chart. So This blue color bar graph shows 2019 data means, and the yellow color bar graph show the 2023 data means, in 2019 and 2023 the sparse vegetation data is almost slightly different between both of these, but and also we can see that moderate vegetation shows the equality between these moderate vegetation, and after it, we have to see that in the very moderate vegetation shows 2019 data consists very low vegetation as compared to the 2023 data. Means there is a bigger difference between these the very moderate vegetation data. From the help of the pie chart, this classification is of very moderate vegetation data, and this is the sparse vegetation, and this is the moderate vegetation, which is both 2019 and 2023 data. So, at last, we have to come our conclusion part. In conclusion, we can conclude that the slight decrease in the vegetation cover in urban, slight decreasement in sparse vegetation as compared to 2019 data. And the moderate vegetation has also very slightly decrement, or we can also check the equality between of both of these 2019 and 2023 data. But in the moderate vegetation increased 2023 as compared to 2019, as we previously recently watched our bar graph or the pie chart, it means the vegetation level is slightly increased between the time period of the 2019 and the 2023 data in the district of Alban. So this data was calibrated using field data from 2019 and validated using the data from 2022. The time series of normalized triple vegetation index was derived at the annual scale to access changes in the vegetation cover. So here is our references. So thank you.